I'm really excited and thrilled to be the moderator of this discussion today. Thank you very much, everybody, for being with us. Thank you very much to the audience for making today. Before we dive into our discussion, let me briefly introduce our distinguished speakers. Well, we have Mr. Ch.Hoskinson. He's the founder of Input and Output Global, the company which is behind the Cardano blockchain. He and his team have pioneered a research-first and mathematically rigorous approach to blockchain, and he has advanced significantly the state-of-the-art in decentralization and in digital identity. Thank you very much, Charles. Welcome. We also have with us Mr. Carlos Vargas-Montero, who is the Vice President for AI and Integration at Input Output Global, and he is leading efforts to combine artificial intelligence with the next generation decentralized systems. Thank you, Carlos, for being with us. We have Professor Diamantaras. He is a professor in the Department of Information and Electronic Engineering at the International Hellenic University, and he is also serving as Vice Rector at the university. His research interests span machine learning, pattern recognition, signal and image processing, and augmented and virtual reality. Thank you, Professor Diamantaras, for being with us. We have Mr. Nikolaos Tsoniotis. He's an engineer, entrepreneur, and product strategist. He currently serves as product director at KINVENT. He's also a business angel. He's one of the founding members of HIBAN, the Hellenic Business Angel Network. And he is also a seasoned mentor who has coached dozens of startups in the past. And last but not least, we have Dr. Konstantinos Votis. He is a senior researcher at the Information Technologies Institute at CERTH, where he directs the Visual Analytics Laboratory. His work focuses on applied AI, digital health, and data-driven innovation in highly sensitive and user-centric domains. Thank you, Konstantinos, for being with us. Now, before we start with the questions, I would like to briefly outline the structure and the focus of our discussion. Well, we have blockchains and AI. They are both widely recognized as being disruptive technologies. They change the way we interact with data. They change the way that we make decisions. They change the way we establish trust in digital environments. On the one hand, we have AI, which helps us make sense of vast amounts of information. On the other hand, blockchains, which infuse transparency, trust, and decentralization. So our aim today in this discussion is to explore how these technologies can work together in order to build, let's say, a digital future which is more trustworthy and more privacy preserving. Now, there are going to be two rounds of questions. In the first round, we're going to concentrate on challenges and opportunities that emerge from the convergence of these two technologies. And in the second round, we're going to focus more on practical implication and entrepreneurial perspectives of privacy-first decentralization in the AI era. So I would like to start. Sorry, is that right? Okay, sorry. So I would like to start the first round of questions with Charles. Charles, you have suggested in past interviews that Ethereum, the way that we know it today, may not be relevant a decade from now. And this is due to various issues with this architecture and governance. Now, Cardano, on the other hand, was built on formal methods. It relies on mathematical attestation and rigorousness. And these are the very principles, I think, that also ensure its longevity. Now, I would like to ask you if you agree that in an era where AI generates smart contracts, formal methods are poised to face novel verification challenges, and how Cardano can transform itself or evolve in order to accommodate those challenges.
Okay, well, so with formal methods, you kind of have two directions you can go in. You can go in the direction of, tell me what it's supposed to do, or you can go in the direction of, I'm going to prove it actually does that. So you can either write a specification or you can be proving a property of the system. And you have to do both. So when you build a formal system, really the purpose is to be a blueprint for software to emulate. And then you also want to verify that when the software is running, that you don't run into like a Solana style issue where the network stops for some reason and you're not entirely sure why. The challenge with distributed systems and cryptography is these are the two most delicate domains of computer science. With distributed systems, you tend to have non-determinism inside the system, meaning that stuff just happens and it doesn't really make sense why it's happening. It's an emergent property of the system and you can't really get to the root cause of it and you just hope that it'll go away. And you can even see when people are brilliant engineers, like the recent Amazon bug. Amazon has some of the best engineers in the world. They're $1 trillion company. They have military customers, all these things, yet somehow, some way, they screwed up and the whole internet went down because of probably a stupid configuration issue that in isolation doesn't seem to be an issue, but in actuality emergently becomes an issue after a series of cascading failures occur. So formal methods really, really help you reason about that, and they really help you get to a point where you get some consistency across the board for the different implementations of the system, that the system works well. Now the challenge with formal methods is that it's very slow, it's very time consuming, it's very expensive. It requires a lot of domain-specific knowledge. You have to know like what cubicle theory is, or you have to know like dependent types and these things. Yeah, oh my lord. There's a lot there, and then you also have to decide your approaches like property-based testing or model checking. If you're going to do code extraction, improve by simulation, and all these other things, it's a word salad because you get a PhD in it. It's a topic, it's a domain unto itself, and there's diminishing returns for it. So the approach for Cardano was always invest heavily in getting it right, especially in the translation of the research, because we have 250 academic papers we've written to a specification. And then over time, prove properties of the system so that you can prove reliability over time, which is why Cardano gets more reliable despite the fact that it gets larger and more complicated, which is a big payoff for the investment. This does not solve, though, the competitive issue because Pro Methods doesn't make any prescription of what you should build and why you should build it. You still have to have product function to decide that. And then with respect to AI, it actually helps tremendously with AI. To answer your question that you asked, the AI requires constraints. So large language models hallucinate, and you need some form of constraining quality assurance function that basically the LLM can come back to and say, does this output I've produced match or satisfy these things? So actually, by having formal specifications, you dramatically increase the probability that the output of the LLM will be not garbage. It'll actually conform and work well. And a lot of progress that's right now in vibe coding. Amazon recently released a framework, and Claude is working on this, as are others, has been not in the code generation, the raw code generation capability, but in involving agentic workflows where some of the agents actually have built within them specifications and contracts that protect the output and check the output. So I think we're very well suited to be quite competitive in that world because we're the masters of formal methods inside the space. We and only a few other ventures have chosen to embrace it at a very deep level, and we're polyglot. We work with Agda and Lean and other languages. We even write programming languages that are specification languages for our languages and have a light touch to all of that. But again, that's not a product function, and it doesn't tell you what to do. It just, once you've decided what to do, you can communicate that in an unambiguous way to the entire world, and then you can identify a set of things that you're not so sure about, and you can write proofs to verify safety and liveness of the protocols, or verify that the cryptography is not subject to side channel attacks or other such things, and that is really required for engineering at this level.
Do you also see probabilistic model checking or formal methods being part of this?
Oh, of course, and that's quite useful, especially when you're doing network simulations, because it's impossible to enumerate the entire state space. So you just have to probabilistically check various things. And there's a litany of topics like fuzzing or other things where you have good prescriptions on what to do. And so anytime you have a combinatorial explosion of the explicit state space, you need to use some form of probabilistic methodology to verify that there's generally speaking, going to be good behavior inside that system. Network optimizations, that's where we see that the most, and the interplay between the layer 1 and layer 2 parts of the systems.
Thanks very much, Charles. Now, the discussion around AI-generated smart contracts naturally leads us to wonder about the role that AI might play, not only in creating the smart contract, but also actively governing the ecosystems in which these smart contracts operate. So now I would like to ask Carlos, as AI becomes more capable and powerful, do you think we could see AI systems actively managing community funds or suggesting updates to the network? And if yes, how can we make sure that these AI systems act responsibly and in alignment, let's say, with human values?
Yeah, so I like to think about the capabilities of AI from the perspective of what type of decision you are making. Computers have been making decisions for us since the beginning of their existence. It's just that it has been small decisions so far. LLMs provide a little bit more capability, but as you start increasing the kind of things that you can do with AI, you start tapping into that borderline between what is just a shallow decision and what is actually good judgment, or what is wisdom. From the examples that you provided, for example, managing community funds, that is probably a really bad idea because that requires a great deal of judgment and a little bit of wisdom. And for that, you will always need to bring back the people, the human. So I think it's important to understand what are we trying to accomplish. Whenever we go beyond what is happening on the base chain, and we need to design how people collaborate within that chain, and like the principles of governance, you will inevitably have to think beyond just the decisions that are being made and how decisions are achieved. What is the process? And AI is not there yet. In terms of making transactions, receiving payments, AI will be very good at doing that and will be participating and will be contributing. But whenever you get into higher layers, I don't see that happening.
Thank you very much, Carlos. Now, let's change a bit our focus and concentrate on swarm learning. Professor Diamantaras, swarm learning extends federated learning by using blockchain to, let's say, coordinate decentralized model updates without using a central aggregator node. This sounds great, but as far as I know, the research in implementing such systems is still in a nascent stage. So I would like to ask you, which are, in your opinion, the most pressing challenges in making swarm learning viable at a larger scale? For example, how can we address robustness, fairness, and convergence under heterogeneous and possibly constrained nodes that run in the cloud continuum, and at the same time keep blockchain synchronization efficient?
Thank you very much for the invitation, first of all, and the chance to talk to you. Very, very excited to be here. Before I answer the question, I might take 4 minutes instead of 3. I hope you accept that. I have to explain how machine learning works, very basic. Essentially, you have a model, typically a neural net with a few hundred or 1,000 or million parameters, and you have the data X. You plug it into a machine learning algorithm, stochastic gradient, for example, and the algorithm generates the deltas of the weights, so they're updating. These deltas are known as gradients. Typically, machine learning models are owned by entities. So, for example, OpenAI owns ChatGPT. It has the weights, it has the data X, and it has the updating algorithm to update the weights as new data come in, right? Now enters democracy, a Greek word, by the way. Democracy as opposed to oligarchy. Right now we have an oligarchy, right, of AI, oligarchy of OpenAI, Google, Perplexity, whatever. So how can we cooperate? We are 50 people in this room, right? Suppose I have a little bit of data, you have a little bit of data, he has a little bit of data, and we have a common model and we want to train it collaboratively. That's called federated learning. Swarm learning that Simos mentioned is an approach where nobody is the leader of the group. So typically what you do, here enters the question of trust, and I don't trust you. You are maybe in South Africa, maybe I'm a hospital in Thessaloniki, maybe you're a hospital in South Africa. We don't want to exchange our data. It's illegal, actually, due to GDPR in Europe. I cannot actually do that. So what do is I use my little X locally, train the data, train the model, and I submit to the blockchain, which is actually a mechanism of building trust and accountability and all those nice things that mentioned before. So, so enters the question of trust. I submit to you the deltas, the updates, right? You don't get to see my data. But then there's the issue, okay, of course, privacy. You don't want anyone to look at my data and spy on my data and go reverse engineering and deduce X, right? For that reason, I don't have much time to explain. There are some methods to defend yourself against these kinds of attacks. For example, differential privacy, where you actually add a little bit of noise to the gradients, making it impossible for the intruder to deduce your X. Then there is the issue of, okay, I don't get to see your data, I don't trust you, so how do I know that you submit legitimate deltas? Maybe you're submitting noisy deltas just to destroy the model. Maybe you're a malicious node, right? Then there is a consensus, again, built by supported by the blockchain. So there are mechanisms where you look at the gradients, and for example, the simplest thing is to take away outliers. So basically what happens in swarm learning is that there's a node in the group, not the same node every time, different one to have fairness. But this guy aggregates our deltas. You bring some deltas, he brings some deltas, I bring some deltas, right? Somebody has the task of aggregating those, adding them together. So there's an issue of how do I know that your deltas are legit? So rejecting outliers is one of the approaches. I don't know how I'm doing with time. Not very good, huh? Okay, sorry. Then, okay, I'm going to go really quickly in 3 minutes. I cannot go through many details, but the next question is how do you trust the aggregator? For this reason, there are some secure protocols to do multi-party computations. There's also trusted enclaves. Maybe we'll get a chance to talk about those later. And the last but not least question has to do with fairness. Maybe my hospital has 10,000 records and a supercomputer, and so it can submit thousands of deltas every second. Maybe your infrastructure has only a couple of patients and can only submit in a laptop and can only submit one update per 10 minutes. So yes, this is also a very, very, very important question, and it can be addressed again with some incentives or punishment to those who tend to submit a lot, or there are some strategies to address the issue. For example, making the updates of someone who updates a lot, making them smaller, for example. So this is a very active area, very new area. There have been some pilot applications of swarm learning. Maybe I get a chance to talk about that. I'm sorry, I'm taking too much time. I apologize.
Thank you.
Sorry, I'm sorry, yes.
Thank you, but you already covered, I think, my second question in the second round,
Okay.
where I was going to ask you which is, in your opinion, the best combination of those cryptographic and statistical privacy techniques like differential privacy, homomorphic or searchable encryption, the trusted enclaves. Which combination do you think is going to be?
You want me to ask an answer now?
Yeah,
so okay, I skipped the second round. Okay, good. Okay, trusted enclaves, trusted areas that are supported by, this is a very good option, is hardware-supported security measures. So you have a node who's supposed to aggregate all our data, deltas. and how can we sure that when we submit those, he's not malicious and doesn't try to do something funny. So there is a hardware support for security there, and we do the computation in plain text. So we submit something in a trusted area, like you can think of it as a walled room, protected.
Sandbox.
Yeah?
Sandbox.
Yeah, exactly, a sandbox. So this is a very good option, except that typically trusted enclaves are small, 200 megabytes perhaps. So if you're trying to do a very big computation, a very big model, then you run into trouble. The second best option is secure multi-party computations. You don't get so good, right?
Well, I mean, we have virtualized TEs now. You know, like NVIDIA's building them, and AMD Sev, and these things.
Okay.
They do them for large language models.
Yeah, but I mean, that's certainly a very good approach, if you can get to overcome the size issue. And it's very fast because you do everything in plain text, so you don't get to do any cryptography fancy
So
stuff.
trusted enclaves. is
I would
our
think
best,
so,
yeah.
yes.
Cheers, thanks a lot. Now, my next question goes to Dr. Votis. Konstantinos, your work spans critical domains like cybersecurity, e-health, and you always have a strong emphasis on integrating blockchain technology in order to enhance the trustworthiness of these systems. Now, one of the key dimensions of trustworthy AI is explainability. So how can, in your opinion, blockchain technologies help enhance the explainability of AI systems?
Thank you for the invitation. I'm very happy that I'm here. And, so regarding the explainability and how the blockchain can support that, in my view, first let me to tell you that blockchain cannot be used for understanding the mathematical logic of an AI algorithm. So we need to understand that the blockchain can support, can advance the explainability of AI. So we can offer a solution, a blockchain solution that they can understand what we can do with the data that are being used, for example, in an LLM, a large-scale model, language model, how this fine-tuned and what kind of data, for example, have been used. So we can use the blockchain in order to be like a immutable control and verifiable log, let's say, layer, as an additional layer that can support the content, the explanation of the content and the context. And through this log layer, you can understand also about, for example, if there is a decision of an AI solution, probably in the healthcare, as you mentioned, you would like to understand what is happening, how this explanation was given, the decision was given. You can store this information, you can have on chain this information in order to go back and try to understand what happened. For example, it was a decision of an AI solution, a healthcare solution, and there was a decision, probably maybe after 6 months, maybe there is another decision. So you can go, you can use the blockchain in order to be a trusted layer for understanding what was happened and try to go back and being used as a control and verifiable, let's say, environment. So there are different methods. We already, actually the first project that we started in our lab was in 2017 when we tried to support the medical issues that you may have when you need to travel. So in Europe there are NCPs, national contact points, that there are some existing infrastructure that it's in different European countries. And there is a huge work in order to be sure that when you are abroad, you can use your wallet, you can use your identity, or the doctors, they can use this infrastructure for giving them consent for using your data or accessing your medical data. We started using blockchain for supporting that. It was a successful project in 2017, and after that, we'll continue also for other projects for supporting blockchain for explainable AI with different mechanisms like decentralized identifiers, verifiable credentials, and many other implementations that we do.
So this explainability actually helps personal data sovereignty, right? Because now people can be in control of how their data, their personal data, get to be analyzed by AI systems.
Yes, and they can understand how this data is being used, who is using our data, and we can control actually our
So you have magically answered the second question as well. Thank you very much, Konstantinos. Now, I would like to ask a question to Nikos. From an entrepreneurial perspective, what do you see as the most promising opportunities at the intersection of AI and blockchain, Nico?
Right. Thank you for inviting me. Humble to be in a panel of academics and entrepreneurs and all that. Let me take a step back. For me, blockchain, I've worked with Kostas in the past. We had long-winded discussions about the whole thing. For me, blockchain is not about trust. Trust is a derivative term that comes out of certain conditions that have to be met. So blockchain becomes a means of accountability for things that take place, for things that happen. And then you build trust if everybody consents. There's a consensus that this kind of underlying technology is the one we are going to be based to do things in our lives. Now, from a product perspective, in KINVENT, for instance, we do devices with sensors for physiotherapists in the medical and performance space. Obviously, we have patient data, we have athlete data, it's very data rich and so on. So we need to abide by certain ISOs and certifications and MDR and QMS and all that process for this kind of data. As long as there's not a consensus that these kind of certifications can suggest or work on blockchain, it's difficult for us to integrate that into our pipeline. Having said that, we integrated AI. And one of the things that we did, which is a very fresh implementation, is that we had all of our public-facing data in our own server with an embedding model that we chosen for relevance and accuracy, and working with an LLM external up until the point where it makes sense to go for integrating that as well. The problem that we had to face was hallucinations, which happens, right? Their LLM systems, our AI systems are based on the fact that they want to pleasure you in a way. They want to give you an answer. They want to give you a resolution in what you're seeking. So they will hallucinate in order to do that, at least up until now. So by bringing everything in our own server, we had to devise our own RAG template prompts, our own system prompts, so that we have zero hallucinations across everything that people ask. In doing that, basically I realized that the system prompt is sort of a smart contract. So where I would see things moving towards is system prompts or things like that becoming the rules that do not necessarily belong to you, but they can be applied with certain conditions and restrictions so that you make sure that the system you're building on AI, meaning, at least abides by these kind of rules. Now, once you do that and you make that available widely, then you have to move on to the ISO bodies and the notified bodies and all that, and have them in a consensus that this kind of system can be applicable and we accept it so that you can move forward. So building a product that is not coming from the theory, it's not coming from the mathematics, it's not Cardano, for instance, means that you have to work in a real world where it's not, by default you don't see that everybody consents that, yeah, this method is secure. Unless this playing field is leveled, then from a product perspective, it's difficult to make decisions. You can do it to facilitate certain things, but that would be your own decision. It doesn't mean that it has the gravitas that it's needed for you in the market, which is a problem for us, which I've worked with Kostas with blockchain, we're working with AI. I mean, we know how to apply and implement these things, right? But from that point getting to a point where these things actually make sense for the business, it's a different discussion.
Thank you. Panos, do you have another?
Maybe take away 30 seconds, not more, because they have to go.
Okay, I'm sorry about this. Yes, so
They were very polite.
please, Charles, 30-second message,
30 seconds, not more, please.
takeaway message.
It's a very interesting hybrid conference for high level, and then we go straight to hardcore theoretical computer science. So thank you, audience, for being so patient. These are very hard topics, but this is how the sausage is made. When we say stuff is trustless and you say you could build society on these systems, you can't do that unless you understand the engineering and science. And what's magical about the cryptocurrency industry is you're combining the best of programming language theory, distributed systems, and cryptography alongside game theory all into one bucket, one mixture. And that mixture is very complicated. It's sometimes hard because we've written 250 papers to know where to publish. Is it an economics paper, or is distributed systems paper? Is this to a PL conference? And it's even harder for people to read the papers, but it's what's required for social infrastructure, because biology is like this. We're used to this in life sciences. The heart is the heart. Whether it's complex or not is not the heart's problem, it's your problem studying the system. Similarly, when you look at a social system, it's a complex adaptive system. It's complicated, it has emergence, it has all this weird system stuff inside of it. And so you need to look at tools from different lenses to understand them. Is it secure? Do the incentives make sense? Will the system self-propagate and self-heal? It's called autopoiesis. Is it self-maintaining and self-healing? There's a lot of concepts and principles there. And the challenge with academia is very siloed. And so you're a cryptographer, but you're not just a cryptographer. You're a cryptographer studying public key systems. You're a cryptographer studying post-quantum public key systems. You're a cryptographer studying post-quantum public key systems and lattice-based crypto, and a very particular type of lattice-based crypto, and you hate that other guy. That's the problem with academia, but then suddenly you have to go zoom out and you see this broad world, and you have to be a cryptographer who's also an economist, who's also a distributed systems expert, who's also a business guy, who's also a political scientist trying to build a voting system and get people to use that voting system. Patience is the key virtue in all of this. You have to learn how to work with others, to listen to others, to learn from others, and you have to have interdisciplinarity. You have to have the ability to have conversations that are uncomfortable because you're no longer the domain expert. As I mentioned with the Concrete Conference, imagine how hard it is to have a PhD in a topic, be a full professor, have 200 publications, and then suddenly you walk into a meeting where you know less than the undergraduate. It's an ego thing. It's very, very hard to walk into those. So the people who tend to do very well are the people who have that perpetual beginner's mind, and they learn new things all the time. And it's always so fun because you get to stay young and you get to do things. But we see the fruits of the labors. This industry has evolved zero-knowledge cryptography and many other fields by decades in less than 5 years. The publication volume, the advancement of technology, these things, and it's getting to a point where we can rebuild and rewire society as a whole.
Thank you very much. Professor Diamantaras.
Thank you very much. I'll be very fast this time. I'm going to talk about swarm learning, as I did before. As I said, there has been a pilot test of that, more than one actually. The results are good. The learning model was close to state of the art, and privacy was also preserved. And so I would say that the swarm learning is maturing. It's not there, but it's maturing. The problems that were encountered was mostly related to the extra costs for using the blockchain. They used Ethereum, by the way, in this experiment, I know. And the infrastructure that is needed, and the cost and the time and the network traffic that is needed. But I'm sure this is going to be heavily researched, and probably it will be solved. I think it's a great paradigm because swarm learning relates to democracy. Nobody owns anything, so you don't have a big company. You have all of us as a community. We own a model, and privacy is preserved, and that's, I think, is going to be the issue.
Thank you. Carlos?
Yep. So I think AI privacy, blockchain, AI in particular, will change the face of what we know as business and society in the next few years. I think key questions there are what exactly would be disrupted by AI? There's a lot of fear nowadays, right? And but there are some properties that will be preserved. Like if we take a look at privacy, for example, privacy ends with lack of human judgment. Like if you give me the best system in the world, user and password, and I start giving it away, that is where my privacy ended, when I started with my lack of judgment. So I think where we will see AI get ingrained into privacy chains and blockchains would be more at the lower layers where judgment is not as important. And the more that we work on the collaboration between AI and humans, where humans get elevated, where judgment is important, where wisdom is important, the more that we would be poised to actually change the fabric of society. So I think more than just assuming AI will come and change, is much more interesting to ask the question, how? I can tell you today, my cell phone is much better than myself at countless things. And that I've learned to work with that. So how do we map that to this new technology? I think it is a very interesting question.
Thanks. And Dr. Votis?
As a summarization, to be honest, I'm very happy that I started working in blockchain since 2016, when we set up the first team in CERTH and also in Greece. We are very happy that we have, together with the Greek Ministry of Digitalization, the EPSI node, one of the two nodes that we have in Greece, EPSI, European Blockchain Service Infrastructure. And I believe that the integration of blockchain with AI will be amazing of what we will see. I see blockchain as a trustworthy wrapper of AI processes. And I believe that all of these, let's say, technologies, they can work together, and we believe that everything is happening in order to see trustworthy AI advancement for all of us.
And I think that blockchain is a great enabler of AI because it allows for all this trust to be placed in the AI agents. And finally, thank you, Nico.
Yeah, I'm going to say something bleak before I get back to. So, societies have been built on blood, fraud, and manipulation. This is how you build societies. I can't think of anything that I've been taught in history that doesn't have one of these aspects. So it's a dual problem. It's not a technological problem per se. Technology, you can get the brightest minds working on it. You will find solutions. You will find the best solution. But it's also a societal problem. And these two have to be solved together. And I'm coming back to what you said, Charles, about this is not a today thing. This is a generational thing. We have to evolve as humans to get to a point where we agree that these kind of technologies are our go-to processes for democracy, which democracy, by the way, is a joke as a term, right? It doesn't work this way. I mean, if you just step back and see things, the broader picture. So we have a long way to go before we get to the point where we see the full spectrum of what's possible. But building, and now I leave the bleak part, but building towards that future means that slowly but surely you're going to get not followers, but people who abide by the principles. So to me, it's a first principle thing. We have to work on our society and how it perceives life on our planet in general, before we get to a point where everybody agrees that, yeah, amazing technology, let's actually use them, right? Because if I go back to the example that you said about me and somebody in Nigeria who could be put in jail, you might have the best blockchain solution, but the government would just choose and put that man in jail. It doesn't work. The fact that he has verifiable and accountable data on the blockchain doesn't mean that the government will not put that man in jail, right? So there's a long way to go, amazing technologies. I'm a geeky towards that kind of stuff myself as a product guy. Amazing technologies, but it's a first principle and it's a philosophical, way moving forward for the human race as a whole. So, yeah.
Thank you very much, Nico. Thank you all. Thank you. Thank you.
The denominator values. We need to solve complex problems. We need interdisciplinarity. So I agree with this because I'm an interdisciplinarity person. First degree in economics, master's in computer science, PhD in health informatics. Okay, then when I came back, I started working. I was the first president of a logistics association, and so on. You know the stories, and most of you that you know. So Popper said that, the philosopher, 1965, interdisciplinarity could solve complex problems. Currently, we are in that era, complex problems, so we have to find the best economists, the best computer scientists, the best psychologists maybe, and because they understand about human intervention, we have to put them together and then we'll thrive. But the denominator should withstand values, trust, whatever you want to do that, otherwise we cannot move forward. Synergies brings, trust, and thank you very much, the input-output team, Charles, Carlos, Tamara, and all the team back there, and many others, new friends that we made. Thank you very much for spending so much the time with us. You inspire us. Thank you, my excellent friends and speakers here. And most important, thank you for coming today. All the best, I wish you.